Right now, you are completely surrounded by invisible activity. You can send a text message across the city, heat up your lunch without lighting a fire, stream data from a satellite orbiting the Earth, and feel the warmth of the sun on your skin. All of these things happen without a single physical wire connecting you to the source. But how does that energy actually travel through empty space? If there are no wires, no pipes, and no physical tethers, what is your text message physically writing on to get to its destination? To understand how this invisible communication works, we have to look at a concept in physics that dictates how our universe is mapped. It is called a field. To a physicist, a field is a three-dimensional map of a specific physical space, like the interior of a standard room in a house. This 3D diagram shows how that mapping works. If you measure the temperature at every single point in this living room, you get a map made entirely of numbers. Because temperature only requires a magnitude, a simple number, physicists call this a scalar field. But maps can hold more than just single numbers. Imagine stepping out of that static room and into the dynamic environment of a thunderstorm. To map the wind in this sky, a single number isn't enough. You need to know the speed of the wind, and you also need to know its specific direction. Because this map requires both magnitude and direction, it is called a vector field. Fields are just maps of information, and once you can picture a vector field, you have the mental tools to see the invisible ocean that surrounds us every day. If we pull back from the weather, the actual space around us is filled with two very specific invisible vector fields. They are the electric field and the magnetic field. Here's the first rule of how they work. When an electric charge is completely stationary, at rest, it produces a static electric field. But when that exact same charge starts moving, becoming an electrical current, it creates a magnetic field wrapping around the path of the charge. For decades, scientists observed these two phenomena and believed they were entirely separate solo acts, operating completely independent of one another. That understanding shifted with Michael Faraday. Through his experiments, Faraday proved that a changing magnetic field actually gives birth to an electric field. James Clerk Maxwell later provided the mathematical proof for the inverse. A changing electric field generates a magnetic field. This animated visualization shows how these two fields operate as a coupled system. A pulsing electric field on the vertical axis spawns a magnetic field on the horizontal axis. That new magnetic field immediately spawns a new electric field, and the cycle repeats. They constantly leapfrog off of one another. This continuous, self-sustaining chain reaction rippling outward through space is an electromagnetic wave. It is the primary mechanism for transmitting power and information across the universe. This theoretical chain reaction drives almost all modern technology. The only difference between these applications is their frequency, which is simply how fast those two fields alternate. This graph illustrates the electromagnetic spectrum. On the far left are wide, slow-rippling radio waves carrying Wi-Fi. Moving slightly faster are microwaves used for satellites. Panning right, the waves compress and vibrate much faster, becoming visible light. Compress them further, and they become X-rays. Because those high-frequency waves are so tightly packed, they pass through soft tissue while reflecting off dense bone, allowing doctors to see inside the human body without a single incision. From the heat warming your food to the light reaching Earth, it is the exact same phenomenon, dancing at a different speed. The smartphone in your hand relies on these principles every second it is turned on. Every text you send and every video you stream is a deliberate, engineered manipulation of this invisible, universe-spanning ocean of electric and magnetic fields. Now that you can visualize the fields and see how they move, you have the foundation you need to dive into the math and mechanics of electromagnetics.